Right, question number 1. What is combustion? Let's hear the chat.
Ma'am,
Yes.
a combustion is a mixture of two different elements to create a element.
I believe,
Well,
say it again, Michael. Okay, Christopher said it is the burning of an element in the presence of oxygen. Yeah, so combustion is when an element or a substance is burnt in the presence of oxygen and sometimes even water, right? And we get heat and light energy from combustion. What part of air supports combustion?
Oxygen.
Well done. What is the general equation for a combustion reaction with metals? Remember, the general equation is like a metal plus what, that kind of thing. Okay, so Christopher said a metal plus an oxygen gives me a metal oxide. Right, guys, why is this a general equation? Think of it that it's like a mold for all metals, right? So I can put any metal here. I can do calcium, potassium, magnesium, sodium, and if I add it to oxygen, I'm always going to get a metal oxide. I'm going to get sodium oxide or calcium oxide or N oxide out of it, right? What energy conversion takes place in the combustion reaction? So tell me, what is the energy we are originally sitting with and what does it transfer into? Mulemo and Kian, why are you guys late to my class?
I couldn't connect, ma'am.
Huh?
I couldn't connect, ma'am.
Okay. Yes, so there is a change from potential energy to heat and light energy. Right. Yes, well done. Okay. Name the products to be formed by the combustion of these metals. When sodium burns in oxygen, what is my product? What's my metal oxide? Good, Gabby. It's sodium oxide. When potassium burns in oxygen, it's potassium oxide. Okay. Present the reaction between potassium and oxygen in a chemical equation. So that one's simple. All you need, remember, when it's a chemical equation, it's not words, it's using symbols, right? Symbols are like O and A, etc. So we have K plus O2. Well done, Mo. Just change KO2 now. Right. Oops, not allowing me to do this. Anyway, so we have 2 KO, right? And then there's a 2 before K. Right. And I see Gabby has nailed it there. So why don't we have a 2 next to oxygen here? Because as soon as oxygen combines with another substance, it loses its 2. It loses that diatomic property. Okay. Did you know that all the diatomic molecules, the 7, I have no fear of isophobia, all of them are gases. And what tells you that they are gases is their diatomic property. Anytime you see O2, N2, H2, all of those are gases. But when you have potassium, which is a metal, and combining with oxygen, then you get a solid mass, correct? A metal oxide. Write out the chemical equation for the combustion of steel wool. Who can do this one? This one is, you really got to think for it, eh? Because you got to ask yourself, what is steel wool? Oh, wow. See, Gabby has answered me. Yeah, so we start with Fe, which is iron, right? Plus oxygen, right? And we are left with Fe2O3. For this one, you just need to learn off by heart. Just learn Fe2O3 off by heart. That's like the only thing you need to learn off by heart in this subject, right? So we start with 4Fe, and I'm just going to write the balance equation. I think it's 3 and 2. Yeah, that's the balance equation. Yeah, and we done this atomic number yesterday. So let's go to the proper lesson that we are doing today. Today we're going to be talking about rusting. Okay, we're going to be continuing the lesson, and it ties up with combustion of metals, because every time iron or any metal is exposed to oxygen, a combustion reaction occurs. All right, the oxygen in the air reacts with the metal surface, which creates iron oxide or an oxide, right? And this oxide is it's really not nice to look at. It's usually like a black mass. Okay, it makes things brittle and makes things fall, right? Rust is a form of corrosion. Corrosion is when something is eaten away. It only occurs on the surface, and this will, Gabby, to answer your question, everything is on Google Classroom. So I posted it, I think, last week. I posted the guidelines for the test, right? So just look for that post. All right, so I said that rust is a corrosion, and it occurs on the surface of an iron that is exposed to moisture and air. If you leave your bicycle outside in the rain, right, because of that water and that combination of air, you're going to wake up to a rusting type, what do you call it? A rum or something. So rusting is the chemical reaction between iron, oxygen, and water. When iron is exposed to oxygen in the air, a similar reaction occurs, but much slowly. The iron is gradually eaten away, and we don't say eaten away, we say it's eroded, as it reacts slowly with oxygen. Under wet conditions, iron will rust more quickly. Corrosion is a chemical attack on the surface of a metal, causing it to erode or fall off. Erode means to I don't know if you guys ever seen like a video where they pour acid and there's a hole created in a substance. Rusting tends to happen much faster near the ocean. Not only are there water droplets in the atmosphere, but these droplets have salt in them, and this makes it even more corrosive. Rusting also happens more quickly in the presence of acids. Inside laboratories, factories where acids are used or stored, the air is very corrosive. Okay, like if you buy earrings that are cheap, on the cheaper side, and they're not coated with extra metals, then you see they'll rust very quickly, and that's not good for your health. And I don't know if you guys have seen a picture like this with a car that is rusted and on the sand. That usually happens in moist climates, like in Durban or in Cape Town. Okay, all right, and then a very important thing, fruits also go through rusting. And how does that happen? When you cut, when you leave a banana open, or you cut open an apple, and then after a while it's going to brown, right? And that browning is because what element do we have in the fruit that is reacting with oxygen and causing the browning? Tell me in the chat. Potassium is a metal, yeah. But what's the one metal that reacts with oxygen and creates rust? We even have it in our blood. Our blood smells of it. It's like a strong metal smell.
Ma'am, why does it?
What is it?
Why does blood smell like that?
Because it contains iron, right? Iron has that smell, like I don't know. But yeah, because it has iron, that's why. So guys, let's to prevent rusting, okay? So there are three methods we're going to be talking about today. The first one is paint. you'll see that like on the windowsills and stuff in school, maybe even in your house, people have painted the sills, right? And we paint it because we want to create that layer between the atmosphere and the actual metal, right? But painting isn't the best way to prevent rust, because after a while you get this sort of effect, okay, where the painting sort of crusts off, it flakes off, and then the moisture in the air can reach the bottom layer of the metal, right? So painting is good, but it's a temporary fix. Then we have oil grease, right? So like moving parts of a machine can be covered with a layer of oil or grease. It's also not the most effective method, and can you think of a reason why it's not the most effective? Like if you have a door that's making a noise, then you usually grease it, right? But why isn't it the best method?
Ma'am, because oil runs dry after a while, and then yeah.
Yeah, exactly. It runs dry and you have to keep replacing that oil, right? It sort of evaporates into the atmosphere. Okay, and then the third way we have is electroplating. Now this you see everywhere you go, right? Your taps are electroplated. The doorknobs are electroplated. Your folders are electroplated. And what exactly is electroplating? So we basically cover one layer of metal with a stronger, more resistant to rust layer, all right? And that's usually with the elements zinc or chromium. Okay, guys, so before you have like this rusted piece of whatever metal part this is, and at the end you have a strong finish that isn't going to rust very easily, like your stainless steel pots and pans, as well as your spoons, right? If they have a high quality material, if they've been electroplated, which just means that a more resistant metal is coated over the original metal, then it's never going to rust. Okay, and here's more pictures of rusting. There's an entire ship that has rusted after a few years, probably. Yeah, and so this is the end of the lesson. I told you guys it's going to be short. Happy studying, guys. And if you have questions, you can message me before 10 p.m. today. Okay. Have an awesome day.
Thank you.
Oh, and Michael,